Okay, so we've got a log equation here. First thing to do is look at the bases of the logarithms. So when we look at the bases, we see base 2 and base 2. So base 2 is a good thing. So we could combine the logarithms here. Base 2, base 2. So that's actually a really good idea. This question is an interesting one because looking at it, we can actually approach it in maybe two different ways. So let's have a split screen there and let's look at the two ways. We might name the methods afterwards. So one of the first things you might like to do is get the logarithms to the same side. Log base 2 of x minus 2 squared minus log base 2 of x minus 2 equals to 2. I'll do the same on here because the first stage is exactly the same. Now if you notice what's in the bracket is x minus 2 and x minus 2. So we're taking log base 2 of the same thing. Oh, my bad. X minus 2 here, okay. So you could do something quite interesting with an easy change of base, an easy logarithm rule, which is the power rule for logarithms. So we could bring that 2 down. 2 log to the base 2 of x minus 2 minus log to the base 2 of x minus 2 equals 2. Now it looks a bit strange, how do you actually go about it from there? But if you think about this, let y equal log to the base 2 of x minus 2, all you have is 2y minus y equals to 2. This is just y equals to 2, right? You don't have to use this idea here. You can just look at the question, 2 of something, subtract 1 of the same thing, leaves you 1 of that thing. Okay, but this might just help frame your thinking a little bit like this. So what we have here is log to the base 2 of x minus 2 equals to 2. So we've got the x in one location and we just basically do anti-logarithm, or we just translate into exponential language. So here x minus 2 equals to 2 squared, therefore x equals to 6. Okay, so there's method 1. That's using the power rule. This one here is going to be using slightly different. This is going to be the addition rule. Well, the addition subtraction rule. Now remember, we've got logs of the same base and there's a subtraction happening here. So we can convert to a single logarithm, but that single logarithm turns into a division. And now from here I will unpack. I will just translate into exponential. Now here's the key area. Something that we can't do, and it's so tempting, is to cancel an x minus 2, an x minus 2 here. This is an interesting question because that leads you to the same answer as you've already got on the left hand side, x equals 6. But anytime we cancel through by a variable, we actually lose a solution. Now in this situation, the solution we use is not valid anyway, but let's see what I'm talking about by finishing off the question. So instead of cancelling, we are going to multiply by x minus 2. Then expand here. I'm going to tidy up. Okay, so now solving this, can you see it's a quadratic? So there's going to be 2 solutions here. So here we've got x equals 6 or x equals 2. And can you see that the x equals 2 is the solution that we would have lost if we'd have gone back to here and divided through by x minus 2. So one of the golden rules of rearranging algebra or working with algebra equations is never divide through or cancel out part of the variable. It just so happens, however, in this case, if we think x equals 6, think about substituting it back in to the original equation. When we substitute 6 in here and 6 in here, you can clearly see we get 4 inside the bracket, and we can take the logarithm of 4. But now, can you think if you change that to 2, can you see the problem? 2 minus 2 is 0. We can't take the logarithm of 0, so therefore 2, or anything less than 2, we just can't have as a solution. So 2, we just put a little cross by it, and we can just say, fancy word, inadmissible, or we can just say x cannot equal to 2. Alright, so that's the tough question.